Hello, everyone. Hello. My name is. Thank you. Thank you. Thank you. My name is Minkyung Kim, and I'm so thrilled to be here in Shanghai, a true hub of technology. Now, let me try my greeting in Chinese. 大家好，下午好。我叫金王刚，来自韩国。很高兴见到您。你吃饱了吗？ Thank you, thank you. That's it. I'm so thrilled to be here and meet all of you. And before we dive into session, I would like to share a bit of my background so you can get like what you can take away from today's session. So I studied education, and then after that, I worked as a teacher for 7 years. And it was during that time that I got interested in coding. So I decided to seriously explore coding. So I joined Apple Developer Academy as a learner. And there I learned how to make an app. So with my team, I made an macOS app called iWaiver, which places large volume of PDF pages into numbers file. And then the next year, I joined Academy as its first learning development mentor. And later, I earned another degree in computer science. And also, I'm doing my master's in ad tech right now. So I'm researching fields like gamification or content design strategy, like everything related to ad tech. And now I'm expanding my role as a learning lead at the Apple Developer Academy. So I'm taking care of all of the learning experiences in Academy, and I'm in charge of strengthening my fellow mentors' educational skills. So as you might have guessed now, I'm an education specialist, but I'm not a technical expert. So I'm someone who understands technology, but if you were expecting me to show like code, then you might be a little bit disappointed. I'm going to share what kind of strategies you can take to your app, and you're the ones who can actually bring them into life. So you are the technical expert. And now, so what am I here to talk about? Let's go back to the title. It's designing adaptive UX through learning theory and AI. So what does UX have to do with learning? Think about the moment when you first download an app, then you're trying to figure out that app. So where are the buttons? How does this feature work? How do you get to the menu? Like you're trying to understand that app. So basically you're learning the app. So in that perspective, I'm trying to see that user experience as a learning experience. And when we do that, we can get some hints from educators because they have spent decades trying to provide useful guide for learners. So they have been answering questions like, how do we help learners persist instead of giving up? Or how do we provide the right level of support so learners can learn independently? And last, how do we keep learners continuously engaged? But since we are trying to see in the perspective of learning experience, so how about replacing the word learn to use? So let's try that. How do we help? Can you try to change the word from learn to use? How do we help? Thank you. How do we help users persist instead of giving up? And how do we provide the right level of support so, thank you, users can use, yes, use. You guys are great. Use independently. And last one, how do we keep, thank you, how do we keep users continuously engaged? So now you can probably see why I brought this learning theories to talk about our user experience. Oh, and I'll briefly touch on on-device AI as well, because it's increasingly important in education field as well. And I'll just take a brief look at it. And now let's go to today's main things, learning theories. I'm going to introduce 3 learning theories today. The first one is cognitive load theory. The second one is ZPD, zone of proximal development and scaffolding. And the last one is the flow theory. So I'll be introducing these 3 theories. Okay, let's go to the first one. This was introduced by Dr. John Sweller in 1988. We all know about working memory, and we all know that it's limited. So the core thing about this cognitive load theory is that we should avoid exceeding this working memory. So when we design an app, when we design a learning experience, we should try to avoid these limits, exceeding these limits. And there are 3 types of load. The first one is intrinsic load. And intrinsic load is inherent complexity of the task itself. And the next one, extraneous load. This is something that comes from unnecessary or inefficient elements that are not directly related to the task itself. So it's distracting the learner. The next one is germane load. This is the effort that learner try to make. They try to build schema. So they are linking their current information with new information. This is where learning happens. So now I have a question for you. Can you guess which one we should minimize? Yep, someone was answering. That's correct. We should minimize extraneous load because that is irrelevant, distracting element. So we should get rid of that so that the learner can focus on the core learning. So we should minimize it. We should minimize the uncluttered layout or with clear instructions and concise instructions. And next one, can you guess which one we should maximize? Yep, you're right. Yeah, you guys were like pointing, yes. We should maximize germane load because this is where our learning happens. And this is where we build schemas. So we should help them learn by giving them like deep thinking questions or self-reflection. So through those, they can build their schema and learn something. An easy one, can you guess which one we should manage? Yes, intrinsic. The last one is intrinsic load. Thank you. Well, we cannot actually make it less complex because it's inherent complexity of the task. But instead, we can try different approaches to make it approachable for a learner. So we can make it as a digestible chunks or like making as a logically sequential guidance so that they can learn without too many cognitive loads. Now, back to our app and a user. If we throw too much at a user, they feel overwhelmed and they experience extraneous load. So we should try to avoid this situation. And this is especially true in visionOS because the screen is much larger and the visual information they are getting is much greater. So we should really focus on trying to reduce the cognitive load when we are designing an app in visionOS. Okay, now let's take a look at some examples where they have applied this cognitive load theory. First one is, does anyone use Chrome here? Thank you. Okay. I'm seeing some of them using Chrome. So if you're on a Mac and you're using Chrome, and if you press Command plus P, can anyone guess what happens? Yeah, print. Print dialog pops up. It pops up, but it doesn't show you 100 settings. It doesn't show you. There are only 3 things. It asks the destination, the pages, the range of page, and the layout, like portrait or landscape. It only asks 3 questions. But if you're a power user and want to do more, then of course you can go to more settings, and then you can approach to more advanced settings. But at first, the system does not give you full settings. It gives you the simplified view. If all of the detailed options were given to the user at first, then they might go through this exceeding cognitive load. So you should try to remove that initial mental barrier. This exact concept was introduced by Apple as well in 2022. It's called the craft of Swift UI API's progressive disclosure. So if you search for this keyword, progressive disclosure, you can find a video. And let's take a look at Airbnb. When you go to Airbnb, it doesn't ask you a lot of questions. It asks only one thing, not even a long one. It says where. And then it asks when and who. So let me see how it works. So I'm just answering to only one question, where, and then when, and then who, how many guests. So by chunking these things that learners have to do, they let the user focus on only one thing at a time. So they can focus on the core thing, which is browsing all the places they can choose. So now let's take another look at autofill. I'm pretty sure you guys are used to this kind of screen. So when you get a text with like 2 authentication factor code from your message, you don't go to the message and then copy or memorize it and then go back and type in. This takes out all of the cognitive load, extraneous load, because it focuses on the core tasks, and the other thing they just took out. So it's taking out all this behavioral load from the process. And this is the CAP word. This is the app that won Apple Design Award last year in fun and delight part. And this is another level of taking out this cognitive load because it replaces manual data input. So when you're learning a new word, and if you want to know how to say like phone in Spanish, you had to type how to say phone in Spanish or phone in the dictionary, in Spanish dictionary, but it does this job. The app does that job for you, and you can only focus on learning the new word.
Pan. Tostada. Taza. Desayuno.
Okay, so that was another example of reducing cognitive load. And now I'm gonna summarize the insights from cognitive load theory that you can apply to your app. So use clear language, limit distractions, group related information, avoid unnecessary details, and emphasize important content. Especially with the last one, if you can signal which information is important, which information you need to focus on, it is really helpful for learning and for user experience as well. Okay, now to the second one, ZPD and scaffolding. The concept of a ZPD, zone of proximal development, was developed by Vygotsky, and scaffolding was developed by James Brunner. And these two concepts are really related to provide proper guidance when learning is happening. So let's find out about ZPD first. So there are three zones, A, B, and C. So A is something you can do alone. You don't need any help. You've already mastered it. You can do without any help. So it's easy. But C, you cannot do. Even with the guidance, even with the help, you cannot complete this task. This is too hard, too difficult, so it's beyond the level. And B is something you can do with help. And this is where we can help. And this zone, B, is ZPD. That is the zone of proximal development. So that is where our guidance intervenes. Does anyone know what these are, the things that are built outside of the building? Yes, thank you. Scaffolding. This is the scaffolding. So if you think about a construction site, when they are building, they have all of these scaffoldings so that the workers can go higher and build a building. But when they are finished, when the building is stable, when the building can stand by themselves, then they take those out. So it happens same in learning. When you're helping someone learn, you provide this scaffolding. And then, if the learner is achieving, then you progressively take those scaffolding out until you finally remove at all. So scaffolding is this temporary support you provide for learners, and that assistance should fade away. Now let's look at some examples that have applied this ZPD and scaffolding. Swift Playground is the perfect example of an app that have applied this ZPD and scaffolding. So this targets someone who starts coding. So at first, it provides glossary popovers or some command. So they provide every hint at every time. And then when the user progresses to later chapters, then take those tips out. And finally, they replaces those hints to just normal keyboard. They do not give you the hint anymore. So it's giving them the guidance gradually. And finally, you take out all the guidance so that the learner can learn it by themselves. And tips, Apple's app Tips is also another thing. And it applies this cognitive load and scaffolding as well. So when you first download an app, Apple does not give you the complex whole manual or a lot of text to the user. But once you start using it, then they give you the tips, but in small, digestible way. So they give you small tips, and after they master that, they take even them out. So it's giving the hint right at that timing, at the proper timing. So this is a great example of ZPD and scaffolding and also the cognitive load. But these help doesn't always have to be a text tooltip. So if you take a look at GoodNote, when the user draws this crooked shape and holds Apple Pencil, then the algorithm detects it and then they change it into a perfect shape. So it acts as an invisible scaffolding for drawing beginners, and they feel capable and they keep drawing. So this is a help scaffolding in another way for the user. And this is Notion. Notion is a very complex tool. It has a lot of functions. But when you first go in, it says press space for AI or slash for command. And if you press slash, then they give you the guidance. It tells you all the features. And when you hover, it gives you the descriptions and examples. So you can get some help. But if you master these skills, you don't need to do that anymore. You just type in and you just start writing. And there is another video related to this. So it's called Build Dynamic iOS Apps with the CreateML Framework. So with this, the app identifies users' current ability with the potential through data, and it can help you give the timely hint or support to the users. Okay, so now let's look at some principles you can apply to your app with ZPD and scaffolding. You need to detect users' hesitation and then give contextual hint and offer temporary support and fade assistance gradually. You need to take that out and then empower independent action. Our goal is for user is to make them do the task by themselves, so you need to take those out gradually. The last one is the flow theory. I'm pretty sure you all have heard of this. So it's famously coined by Mihai Csikszentmihalyi, and you need to meticulously calibrate the difficulty of the task. So this is really easy thing. So basically, if it's too easy, or if it's too easy, then you get bored. And if it's too difficult, you get anxiety, you get frustrated. So you need to balance the level of the challenge and the current skill of the learner or user. So let's go look at the examples right away. Elevate. This is a brain training app, and when users use this app, it detects the current level of user. So it detects the speed the user is typing or the accuracy of the answer, and then it dynamically calibrates the difficulty of the next task. So user always feels challenged, but it's not too difficult or it's not too easy, so that user can be in a state of flow. Yes, another example is the famous Duolingo. By the look of your face, I think everyone recognizes this app. So Duolingo is a great example of combining all these learning theories, from cognitive load, ZPD and scaffolding, and the flow as well. It has a lot of features in it, and a lot of features help learners engaged. So they try to reduce cognitive at first, giving them the simple lessons, and they give you a lot of tips how to pronounce the meaning, and then they gradually take that out, and also they give you the challenging tasks, and they use streaks or missions or rankings. They bring all the elements, especially something related to gamification as well. They bring those strategies to make users engaged. I'm also a really heavy user of Duolingo. So next month, I'm going to make 2,000 days soon. And when I see this jump here button, I feel like I'm being challenged, and I'm like, oh, challenge accepted. So, okay, so when that happens, I end up learning more than I planned. So I think Duolingo is really smart. And by the way, in a lot of papers in as tech field, Duolingo pops out a lot. Apple Fitness does this very well as well. So it says each week, Apple Watch recommends a new move goal specifically tailored to your activity, so it's easy to stay motivated. So it looks at the past data of the user, and they suggest the new goal, which is still achievable but not too hard. So it is really important to give them something they can focus on that is not beyond their skill level, but which is also not too easy. And these all three learning theories combined together, they have this video of design foundations from idea to interface. This is based on a lot of learning theories, and this is just from last year, so you can check out this video. It covers all of the features like structure, visual design, and navigation, and the content. So I really recommend watching this video if you're interested in. And finally, the takeaways. You need to track user progress and adjust the task difficulty and set achievable goals, balance skill and challenge, and lastly, you need to prevent boredom and also frustration. Okay, let's talk about on-device AI. Well, I know that there are limitations. I know that on-device AI is not a silver bullet for everything, but still, I suggest taking a look at on-device AI first when you try to make your own app, because there are 3 reasons. First is privacy. Learner data or user data is really personal data. Their behavioral data should not be sent to the server, if possible, to keep them really private and safe. And continuity. If your learning or using does not be hindered by all the offline situations like planes or elevators, then your users can just be engaged and keep doing it. So this is the second reason for on-device AI. And the last one is the cost. If you do not have to use cloud-based AI, like every time there is the new input, then you can save some costs. And also for the user, if they do not have to upload and download all the data, then it's really helpful. But yeah, I know that this also have disadvantages. So you need to take really good consideration of which one to choose. But still, on-device AI is also being emphasized in education field as well. And last year, Apple also had another video of bringing on-device AI to your apps using the foundation models framework. So if you're interested in, you can also explore this video. Okay, now let's take a moment to reflect on what we have learned today. The first one was cognitive load. We need to reduce this. And ZPD and scaffolding, we should target ZPD and provide scaffolding. And the flow, we need to make them in the state of flow so that they can learn faster, they can engage deeper, and stay longer. And by leveraging Apple technology, we can build interfaces that dynamically adapt to a user's learning curve. So when you think about adapting learning or user experiences, it's not just about making things smarter. It's about making them more private and sustainable and responsive. So this is my last suggestion. If you notice your users dropping off from too difficult or too complicated UX, then you can help them by designing adaptive UX through learning theories and AI. Okay, that's it. Thank you so much.